Hello everyone, welcome back to another video in our multi-threading in Java series. Before we dive into today's agenda, let's take a quick recap of everything we have covered so far. If you want to skip directly to today's topic, feel free to jump to the next chapter using the video timeline. However, if you are new to the channel, I highly recommend checking out the topics we have already covered. So you will find them really helpful. You can go back and watch those videos if you don't know something already. What are the concepts we have covered so far? We have gone through all the essential building blocks of Java multithreading. We have seen what is a thread class and runnable interface, synchronized block, right? Wait and notify basic usages. While solving problems, we have seen shared objects between threads, how to share objects between threads, right? In medium level, we have seen synchronized with condition based waiting, and post that wait, notify and notify all inside loops. Why you should use wait inside a while loop and all those things. We have solved various interview problems as well, right? These two we have covered. Apart from this, we also dove into some advanced concepts such as Java memory model, volatile, and happens before guarantee, right? In fact, I created two detailed videos just on these topics to help you understand them thoroughly. So do check them out if you haven't already. What are the problems we have solved so far? So far, we have implemented and explained two key multi-threading problems. First one is even odd printer, and second one is print 1 to m using n threads. These helped us understand how threads coordinate and how we can safely manage shared data between them. Now, what's in the store for today? In this video, we are going to explore a very interesting concept in Java multithreading, which is known as semaphores. And to help you understand semaphores in action, we will solve a simple but very fun problem, which is the ping-pong printer problem. If you see in this list, this is the fourth problem which we are going to solve today. This ping-pong printing problem is essentially printing ping-pong alternatively using two threads. Now technically you can solve this problem using wait and notify approach, which we used in the odd even printer problem. But where's the fun in repeating the same method again, right? So let's instead use semaphores to solve it. So you can see how clean and elegant the code becomes when handling alternation between threads using semaphores. So without wasting any time, let's get into semaphores. Imagine a public restroom with 3 stalls, or you can say 3 washrooms inside it. There is a stall manager sitting outside and managing things, and there's a queue of people waiting to use these washrooms. Following are the limitations that the stall manager have put. The first limitation is only 3 people can use the stalls at any given time, because obviously there are 3 stalls, okay, so makes sense. Now next condition is if all the 3 stalls are in use, the next person will have to wait until someone releases the stall, okay. Fair and square, simple. Now let's put some technical terms here and try to explain the whole scenario technically. Now from now on, whatever I will write in blue, that is a technical term which we will later correlate to a semaphore. Okay, so consider a stall manager having 3 permits. When a person goes in and locks the door to use a stall, in technical terms, it is called acquiring the permit. What it is called? Acquiring the permit. So it has taken permit for a single washroom and has entered it. When a person comes out after unlocking the door, in technical terms, this is called releasing the permit. Now another person can again acquire the permit for this washroom and enter. This is exactly what a semaphore is. So Semaphore is a class in java.util.concurrent package of Java, and it has lots of methods, but 2 important ones are acquire and release. Acquire and release, okay? These are the 2 very important methods of semaphores. If we compare with the analogy, semaphore corresponds to stall manager having some permits. Here a stall manager had 3 permits. Okay, so in Java, we write it as Okay. Semaphore washroom permits equals to new semaphore 3. This 3 indicates this particular semaphore has 3 permits. Secondly, someone locking the door and going inside the washroom corresponds to technically washroom permits dot acquire, which means acquiring one washroom. Lastly, someone unlocking the door and going outside the washroom corresponds to washroom permits dot release, which means releasing one washroom. Okay, so we have given 3 permits. This is how you acquire a permit and this is how you release a permit. Now let's get into our IDE and see how it works. Now consider this example where we have created a semaphore named washroom permits with 3 permits. Okay, we have initialized it with 3 permits, which means we can acquire 3 washrooms at a time. Now how we can acquire a washroom? We can acquire a washroom using washroom permits dot acquire. So we have acquired it for the first time, printed washroom permit acquired for the first time. For the second time, printed the same. For the third time, and printed the same. Let's go ahead and run this program. Nice. There were 3 permits. We have tried to acquire it 3 times. We have printed it after acquiring each and every time. So our program has run perfectly fine. Now what happens if I have 3 permits but I try to acquire it for the 4th time? So let's go ahead and do this modification. Washroom acquired for the 4th time. In our analogy, if 3 washrooms are full and 4th person tries to acquire it, she cannot do that because the washrooms are locked. So they will have to wait until someone comes out, right? So similarly, our program should also wait and should not print this 4th statement written here. Let's go ahead and run this. Yes. So our program blocks here, it waits because 3 permits were already acquired, so there is no room of the 4th permit. Now, how do a person releases a washroom? Person releases a washroom using release method. So if I write here washroom permits dot release, what will happen? One among these 3 permits will be released. We do not care which permit is released, but one of them will be released when we write washroom dot release. Okay. Now this will be printed, this will be printed, this will be printed. After that, a washroom will be released, and post that, since one slot is empty, we can again write washroom permits dot acquire, and post that this 4th one will be printed, 4th statement. Let's go ahead and run this. Right, this is done. What if we want to acquire it for the 5th time or 6th time? Let's go ahead and do this. Now if we try to acquire it for the 5th and 6th time and try to run this, again this will not happen, right? Because we have released one washroom, we have acquired one washroom, we have printed this. Now all the slots are full, right? But again we are trying to acquire 2 more. So let's go ahead and run this. Yes, again our program blocks, right? For the 4th time it was acquired because we have released a washroom before, right? But post this acquire, all the 3 permits were again blocked, and so 5th and 6th will not be printed. To print this, what we need to do? We need to release it. So suppose we go ahead and release 2 washrooms here. So if we release 2 washroom here, we are permitted to acquire 2 washrooms again, right? Now let's go ahead and run this. Right? So this time all the 6 statements got printed. Okay. Now here's an interesting and often overlooked behavior of Java semaphores. Let's say you create a semaphore with 0 permits like this. Okay. This means no thread can acquire a permit initially because the count is 0. Let's go ahead and run this. Right? It is blocked because there are no permits available. But here's the twist. You can release a permit even if none were initially available. So it is completely legal to do. Washroom dot release here. If you write washroom dot release here and try to print washroom permit released for the first time. This is completely valid. Okay, so you can release a permit even if none were initially available. This increases the permit count from 0 to 1. Now since you have released it first, it is possible to acquire it now. Okay, so you go ahead and try to run this. We'll get an output: washroom permit released for the first time and washroom permit acquired for the first time. So even if our Semaphore initially had 0 permits, we can release it first instead of acquiring it, and you can create a space to acquire. So in reality, it's like a washroom which was not in use or locked due to maintenance work going inside it. But as soon as it got ready, washroom's lock was opened and now you are allowed to use that particular washroom. So if there was a second washroom which was in maintenance, you can go ahead and release that. If there was third washroom, you can go ahead and release the lock, and now it is possible to acquire lock for those 2 washrooms also. Okay, so if you go ahead and run it, it runs perfectly fine. But you have released for 3 times, you have acquired for 3 times. If you try to acquire for the 4th time, again our program will go and block, right? So this was one of the most important property of Semaphores. So you can actually release more permits than were defined and the Semaphore will keep on counting. This is very useful in cases like producer-consumer problem, which we will see in the later videos. Additionally, there is one more very helpful method in Semaphores which tells you the number of permits available at a certain point of time. In this example, you have 3 permits. You have acquired 1 permit, and after that you are printing permits, washroom permits dot available permits. So number of permits available here should be 2. Okay, let's go ahead and run this. Permits available is 2. One more interesting thing you can do here is, if you want, you can acquire multiple permits at a single point of time. So if you want to acquire 2 permits here itself, you can just pass in a parameter where it says washroom.acquire 2 permits. So if you go ahead and run this, now the output should be 1. Right? Now let's take a previous example which we took where the number of permits was 0, right? And we went ahead and released a permit. So number of permits was 0 initially. We went ahead and released a permit. So now the available permit will become 1, right? So let's go ahead and run this. Available permit is 1. Similarly, in the case of acquire where you passed a parameter, here also you can pass as many parameters as you want. So number of available permits will be 2. Okay, since you have released 2 permits here. So if I go ahead and run this, now the output is 2. Now what I can do is, since our available permits is 2, I can go ahead and acquire permits twice, right? So let's go ahead and acquire it twice. If I acquire it twice and then try to print it, what will be our output? Here our output will be 0, right? So initially after releasing, permits became 2, and post that it is 0. So this is also a very interesting method. Whenever you want to check, you can check how many permits are available. There is also one very nice thing with Semaphores, that is, it has no concurrency problem. So there can be a case when multiple thread can call semaphore.acquire at the same time, but Semaphore handles that internally using atomic operations. So there will be no race conditions where there is just 1 permit but 2 threads have acquired it. Okay, so only 1 thread will be allowed to acquire it. Why? Because all the operations acquire and release, these are atomic and thread safe. Okay, so let's look into the formal definition of Semaphore. A semaphore is simply a counter that controls access to a shared resource. It supports 2 core operations. First is acquire, which decreases the counter and may block the thread if no permits are available. This we have seen in IDE. Second is release. It increases the counter and may wake up a blocked thread. This we will see when we will solve our ping-pong printer problem. What are the properties? So Semaphore manages a fixed number of permits. Only threads that acquire a permit can proceed. Second property is it is blocking in nature. Threads that call acquire when no permits are available are blocked. Third one is its atomicity. Atomicity, it ensures safety that the operation inside the semaphore are atomic. So even if 5 threads try to acquire a permit at the same time, only the allowed number will succeed. Fourth is actually a term that we used in this semaphore world, which is binary versus counting semaphore. So a binary semaphore has only one permit, and if a semaphore has multiple permits, it is known as counting semaphore. Okay, so what I have decided just now is I will give you the ping-pong printer problem statement, give you a hint, and then you should try it on your own using the functions and concepts that we have learned today. Okay, we will dive into the solution in the next video. So what is the problem statement of the ping-pong printer problem? Here you have to create two threads, T1 and T2. Using T1 you have to print ping, and using T2 you have to print pong. And this ping pong should be alternative indefinitely. So our output should be ping, then pong, then ping, then pong, then ping, then pong, and so on. Okay, this should be printed using T1 and this should be printed using T2. Similarly, T1, T2, and so on. Okay, so this is similar to odd even printer problem. Now, what is the hint here? So one hint I will give you, you will have to create two semaphores. One will be ping semaphore with one permit, and another will be a pong semaphore with 0 permits. This is very interesting. Don't look into solution anywhere. Try to solve it yourself. And remember, you have already worked on a similar pattern earlier, like the odd even printer, but there we have used wait and notify. This time challenge yourself to do it using semaphores only. Okay, so don't worry if you can't crack it. In the next video, I'll walk you through the complete solution step by step, and you will see just how elegant semaphores can be. So that's it for this video. Until the next video, stay safe, stay healthy. Bye bye.